Hello and welcome to the channel Binpipe School. You are with Bijayalakshmi, and today I'm going to tell you about the different types of velocity. In the previous video, I had discussed about the definition of velocity and some sums related to velocity. Now let's read about the different types of velocity. Now, when we talk about the different types of velocity, it is of four types. That is the average velocity, the uniform velocity, instantaneous velocity, and the variable velocity. These are the four different types of velocity. Now let's read in details what are these types of velocities. Now, average velocity is the ratio of the total displacement of the body and the total time taken to complete the journey. That is the average velocity. That means here we are calculating the ratio between the total displacement. And we know that the displacement means the shortest distance covered and the total time taken. Now, when we calculate this ratio, we get the average velocity. Actually, the direction of average velocity is the direction of displacement. Now, even when the speed of the object is fluctuating and its magnitude is changing, suppose a body is moving and the magnitude keeps on changing, its direction remains the same as the direction of the displacement. So the magnitude of average velocity is always either less than or equal to the average speed, as the displacement is always less than or equal to the distance covered. Now here average velocity is calculated as total displacement by total time. Now here is a question. A motorist drives 30 km down the lane in 10 minutes. He then returns and drives 20 km back in 5 minutes. Find his average velocity. Now, as per the definition, we know that it is the ratio between the total displacement and time. So here we have to first calculate the displacement. Now, since the motorist is driving 30 kilometers down and returning back 20 kilometers, so what is its average displacement? The average displacement, or you can say the total displacement of the motorist, is nothing but 10, isn't it? So 30 minus 20, that is 10 kilometer. So that is how we are going to put the value here as a 30 minus 20 divided by the total time taken, that is 10 minutes added to 5 minutes. So we get 10 divided by 15, that is 0.67 kilometer per minute. So this is how we are going to solve. Always we should keep in mind to calculate the displacement. If the displacement is not given, we have to calculate the total displacement and then we have to put the value. Here most of the students do the mistakes, which we should always be careful about. Now next type is the uniform velocity. Now when a body covers equal displacement in equal interval of time, the motion is said to have uniform velocity. You can see the picture here. When nothing is, no vehicles are there or no disturbances is there, the car is traveling constantly at a uniform velocity, we can say. Okay, it is covering equal distances in equal time interval. So car traveling at constant speed without changing direction is a best example of uniform velocity. Even the space probe drifting in interstellar space, that is also having uniform velocity. Now uniform velocity here also has, if like as per the definition we have, equal distances covered in equal interval of time. So here you can say 10 meter in every 1 second. So this car is also covering a uniform velocity, and the graph that represents uniform velocity is a straight line graph. Now, non-uniform velocity or variable velocity, that is, if a body covers unequal distances in equal intervals of time, then the motion is non-uniform. That means a motion of a car in a crowded street, a ball rolling over a rough surface, the motion of vehicles approaching or leaving destinations, because while approaching, one applies brake or leaves the destination. It's not suddenly that someone starts at one instant. It gradually increases the speed, isn't it? So that is why here we can say the example as a non-uniform velocity or variable velocity. Now, when the bodies are moving with non-uniform speed, we mentioned that they're instantaneous and average velocities. This is one point to remember. If a body is moving in a non-uniform speed, then we are actually mentioning its instantaneous and average speed. So this is the graph that shows the variable velocity or non-uniform velocity. It's a curved line graph. It can be curved this way or it can be curved down, and depending on the acceleration and retardation that will come in the next videos. Now let's talk about instantaneous velocity. The velocity of an object at a particular instant of time, that is instantaneous speed. Okay, that means the distance traveled in a short time interval to the time interval. This is the ratio of distance traveled in short time interval to the time interval. Now, when someone is driving on highway and you look down at your speedometer, you are traveling at suppose 55 km per hour. Okay, so at that time, it is instantaneous velocity that you are reading. So the speedometer records the instantaneous speed. So for uniform motion, your instantaneous velocity is same as your average velocity. And for non-uniform motion, your instantaneous velocity changes constantly. So actually this is true for most daily situations like driving on busy roads. This is quite common. So this was it. And here is what we have learned from this video here. The rate of change of displacement of the body is velocity, and there are 4 types of velocity, that is average velocity, uniform velocity, instantaneous velocity, and variable velocity. So that was all about the types of velocity. Join me in the next video. Please like, share, and subscribe my video to get updates. Thanks for watching.